So again, we're given a bunch of different tables, and it tells you what kind of function these tables go with, but we're going to try to find a pattern so that if we're just given a random table, we know what type of function we need to get from that. Does that make sense? So if we are looking at our first table here, looking at your y values, what are they doing each time? So from 5 to 8, what did they do? From 8 to 11, what did they do? 11 to 14. And 14 to 17. So what do you think our pattern or our rule is going to be for linear functions in their tables? They're adding something over and over, right? Is it always going to be 3? That could change, right? Just depending on what your slope is. So the pattern here, we'll say as the x's go up by 1, the y's go up by how much? 3. And so think about it. When we're talking about lines, linear functions, when you graph a line, how do you count the slope? Do you remember? Something over something. Rise over run, right? Do you remember that? So your rise is like your y values, right? So how far is this one going to rise? And it's going to run how far? 1. That's your slope. You just found your slope from your table. That was super easy, right? Does that make sense? Yeah. So whatever it is that they're adding each time, that's probably going to be your slope, okay? So all patterns, or what does it say? All linear patterns have a common first difference. That's what this guy is called. When we found what they added each time, we're going to call that your first difference. So your linear patterns have a common first difference. So what that means is that you add the same number each time. So we already talked about the slope here, right? We said that it was that rise over run that we got from our pattern. So could we start to write the equation of this function just from the table? Yeah? So we know that your equation of a line is going to be in what form? And what do we already know there? Our m, like you said, was that number that we're adding each time. It was 3 over 1, so just 3. So we're going to have y equals 3x. And then what does b stand for? Do we know what our y-intercept is? How do we know it's 5? Because that's when x equals 0. That's 5. So your y-intercept is 5. Do y'all remember how to find that in the calculator? How to get the equation from a table? How do you do it? Let's do that. Let's double check our function, make sure it's correct. I'm going to clear everything out. Then where do we go? Where? Where?
Listen spreadsheet.
Oh.
Kyle's like, don't you hear me? So we're going to go to lists and spreadsheets, and then we're typing in that table, right? What do you label the first column? And what do you label your second column? Y. Enter all your data. You're confident in your answer. That's what I like to hear. Apparently. Mm-hmm. Then what do we choose? Mx plus b, right? Because this is a line, linear regression, right? So we're going to hit that, and we'll type in x for x, I'll type in y for y, enter, enter. And what did it tell us our m was supposed to be? 3, and we got that. What did it tell us your b is supposed to be? 5, we got that as well. So are we correct? Heck yeah. Is that okay? You could type your equation in and then look at the table and see if the table matched up to the table on the paper. Yeah, you could do it that way. Questions? Are we okay? So is it absolutely necessary for you to have your calculator to get the equation from the table? You can do it without it. Y'all are smart enough for that. Yeah? Okay. So let's move on to another one. Are we all good with linear? Any questions there? So what's our pattern that we're looking for? Adding some number each time, a common first difference, okay? So let's see if we can find a different pattern for these exponential ones. So what's happening with our y values this time? Well, you see they're getting really big really fast. So we know that it is indeed exponential what? Growth. Okay. But what are they doing? What do you have to do to 5 to get to 15? Times what?
3.
Y'all are fast. What's 15 times 3? So what are they doing each time? Times 3. I would check that with all your numbers just to be sure, because sometimes they will trick you. So 45 times 30, what does that give us? So double check it in your calculator. 135. And does 135 times 3 give you 4 out of 5? Okay. Questions there? Are we all good with that pattern? Okay. So let's talk about it. As x goes up by 1, what's happening with our y's? There we go. So as x goes up by 1, you multiply y by 3. That was a whole lot of y's in one space. So we're going to say that all exponential patterns have a common ratio. So that's what it is when you're like multiplying by something. Instead of like a common difference, so like we added each time, it's going to be a common ratio this time. And so do you think that has to be a whole number? No, because what also happens in exponential growth, you also have exponential decay, and that's getting smaller, right? So we could multiply by fractions as well, and that'll help you get that decay model. So again, we're multiplying by the same number. So let's see if we can write our equation for this one too. What is like your standard form for exponential functions? What goes inside parentheses? We do 1 plus or minus r, right? Do you remember what we called that whole thing? Your b value or your growth or decay factor? Yeah. So I'm just going to put b there because this is going to work for growth or decay. Remember when we do growth, we do 1 plus r. For decay, you do 1 minus r. But if we put b in there, that's kind of just a general rule for all of them, okay? Is that all right? Okay. So also when you run regression in your calculator, it gives you the b value. It doesn't give you the r, right? So if we know where the b goes, we'll be in good shape here. So what does that a stand for? What is our initial amount here? What do we start with? 5. And then that b value, the number inside parentheses. You gotta take a wild guess. What do you think that might be? What are we doing to our y values each time? When you times something by 3, what's another way to say that? If you times something by 2, it's the same as doubling when it's times 2. If you're doing times 3, it's tripling. Do you remember how we said that if you triple or double, you put 2 or 3 inside your parentheses? Right? Well, we talked about that. So we're going to put a 3 here. And you did that on your quiz. Maybe that's why y'all missed those questions. So if it ever says that your population is doubling, what number is your B value? 2. If it says your population is tripling, it'd be 3. If it's quadrupling, it'd be 4. This is at least the second time we've had this conversation. Is that okay? So it's starting to come back to us. If not, maybe jot that down somewhere so you don't forget it, because you got a test day after tomorrow. Are we all right with that? How can we check it? We can run regression again, right? Because that gives us a whole bunch of options for regression. So we'll just choose exponential this time because we know that it's an exponential function. So we're going to clear everything out, and where are we going to go? Catherine, where do we go? Yes, ma'am. We're going to go to list and spreadsheets and enter all our data. What do you label your first column? Second column? Good. Type in your data. Fill in here. He's not in this class. He's in my first class. Sorry. Yes, we have. Mm-hmm. Once we get everything typed in, what do we hit? We go to menu. So menu, just like normal, then what? 4. The menu for 1 is all the same, right? That's what you use for everything that we do in list and spreadsheet. So menu for 1. And then sometimes we do one variable stats. Remember, that's where you find like mean, median, mode, that sort of thing. Your Q1, Q3. That's going to give you all that. Linear regression is what we just did, so finding the equation of a line. We want to find the equation of an exponential function, so you're going to choose exponential regression. That's option A down there. Is that okay? Right. So we'll hit enter. Our X list is called X, our Y list is called Y. Enter, enter. And it gives you that A value and that B value. Does our A value match? Does our B value match? So we're good to go. Is that all right? Questions? Anything we're not sure about, don't understand? This should be a bit of review because we did this earlier this week, right? Okay. So the last type of function that we're going to talk about is a quadratic function. So we need to try to find a pattern here. So look at your Y values. What's going on there? From 1 to 2, what'd they do? From 2 to 5, what did they do? From 5 to 10, what'd they do? From 10 to 17. Is that a good rule? Do you think that's going to work every time? Okay. Are they multiplying by some number each time? Would that work for us better? Okay. So let's see. How did they get from 1 to 3? How do we get from 3 to 5? How do we get from 5 to 7? Is that going to be the same? So do you remember for our linear functions, we said they have a common first difference? They're going to have a common second difference for your quadratic functions. that all right? Okay, so if we're going to describe our pattern here, we're going to say as x goes up by 1, as x goes up by 1, it's kind of awkward to like say this, but the first difference in y goes up by 2. Does that make any sense? So as x goes up by 1, the first difference in y goes up by 2. So I think for those, it's just a little bit easier to remember that they're going to have a common second difference. The first difference goes up by 2. So 1 plus 2, 3 plus 2, 5 plus 2. The second difference is the same. Any other questions right now? So if we're going to write the equation for this one, what is our standard form for quadratics? Ax squared plus bx plus c. Did you say that was so long ago? Y'all have an exam in 12 days. 12 days. And you're expected to know everything we've talked about this year. Not just this unit. Not just the next unit. Everything. Questions there? Yep. 2 more, actually. 2? Technically. Yeah. Week after. It's the first week of June. We all right? And then exam. That's not an option. You just take it again in the fall. If you fail. So to get our equation here, do we know our y-intercept? One. What part of your standard form is that? A, B, or C? C, right? So we know it's going to be y equals something, something, something plus 1. Do you agree?
Yeah.
So you know that C is going to be 1. So can we just guess and check to find our rule here? Yeah. So if you do 1 squared plus 1, does that give you 2?
Yeah.
We got to have the squared, right? So I'm just trying x squared first. So what if we do 2 squared? What do you get? Plus 1. Does that give you 5? Do you think anything else is happening here? Or is it just x squared plus 1? I was x squared plus 1. Let's check 3 and 4 to be sure. So if we do 3 squared, what do you get? Plus 1 gives you 10. If we do 4 squared, plus 1 gives you 10. Does that make sense? So you can do x squared plus 1. Now these are really hard to find just by guessing and checking. This one worked out nicely because it wasn't super complicated. How could we be for sure, or get this for sure? Our calculator, right? So again, we're going to clear everything out, and where are we going to go? Lists and spreadsheets. And we're going to type in all our data, label your columns X and Y. Once we have everything typed in, what are we doing? Menu for 1. And then that's that list that we always want to pick from. What type of function is this? Quadratic. So which option do you think we're picking here? Quadratic regression. That's option 6. We'll type in X for X, type in Y for Y, enter, enter.
Wait, what if we click on number 8? Does that mean it's primary progression 3? Oh, never mind, sorry.
That's quartic. That's when your exponent is 4 instead of 2. Good question. So your A value, it says that it's 1. Did we have that? 1 in front of X squared, is that what we have? Yes. And then your B value, it has 1 e to the negative 13. So what does that e to the negative 13 mean? Anybody know? Do I remember scientific notation from middle school? When you have like 13 times 10 to the negative, what was it? This is 1 to the negative 13. So that's how you write that in scientific notation? You did that in middle school. Apparently we don't remember. So that means take your decimal place 13 places to the left.
Oh.
So take your decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 places. And all these blank spots are what? So what is this super close to? 0, right? So it's like 0.1 or whatever, 0.000001. So your B value is supposed to be what? What is it really close to? 0. So that's why we didn't have a B value in here. It's just 0. Yeah? Okay, and then your C value was 1, which we had that, so your function is just 1x squared plus 1. Questions there? Alright, cool. So the bottom part of your page is now talking about your correlation coefficient. So that measures how well your rule that you just got actually fits the data that you put in. So when you run regression and you look on your paper, your R squared value right there, or look in your calculator, that tells you how well it fits. The closer that number is to 1, the better fit that your equation is for the data that you gave it. Does that make sense? So we just put in some data and it gave us an equation. Our R squared value is a 1. So what does that mean about the function that it gave us? It's like a perfect fit, right? So again, the closer that number is to 1, the better fit that it's going to be. I think we've talked about this briefly before. That cutout point is kind of like 0.8. So anything above 0.8 is a good fit. Anything below 0.8 is not a good fit. Have we talked about that? Yeah, maybe? Okay. Questions on anything right now? Okay, cool. So we're going to do some more together. I'm not going to turn you totally loose on these. We're going to do a couple together first.